Hello, welcome again. We are solving some questions of fluid mechanics and machinery. The topic is hydraulic machine. Question of 46 and 47 carries a common statement. The statement is a centrifugal pump delivers 0.04 meter cube per second of water to a height of 20 meters through a 15 centimeter diameter pipe and 100 meter long. The overall efficiency of pump is 70% and coefficient of friction is uh, 0.15. In the formula HF is equal to 4FL V square divided by D into 2D. Question number 46. The manometric head gulp is option A 30.41 meter, option B 30.67 meter, option C 30.12 meter, and option D 20 meters. And question number 47 is the shaft power required to drive the pump. Option A 17.19 kilowatt, option B 20.12 kilowatt, option C 20.67 kilowatt, option D 19.17 kilowatt. So here the discharge is given as 0.04 meter cube per second, and height is the head is total suction head is given as total head is given as HS plus HD is your 20 meter. Okay, so height is given as 20 meter, so that is summation of suction head plus delivery head. Okay, so diameter of pipe means diameter of suction pipe and diameter of delivery pipe is 15 centimeter, that is 0.15 meter, and length of suction pipe and length of delivery pipe is your 100 meter. Okay, so overall efficiency is 70% or 0.7, and coefficient of friction is there 0.015. So velocity of water in the pipe is Vs, because diameter is same, discharge is same, so velocity will also be same in both the pipes. That is V. Okay, so that will be equal to discharge by area of pipe. So discharge is 0.04 and area of pipe is pi by 4 into 0.15. So that is 2.26 meter per second. And the friction at loss in pipe is HFS plus HFD, or total head loss in pipe is 4FLV square divided by D into 2G. So F is your 0.015 and L is your 100 meter and V is your 2.26, D is your 0.15. Okay, so that head loss in pipe is suction and delivery pipe is 10.41 meters. So L here is 100 meters. Okay, and this represents the total head loss due to friction. Okay, and L is your length. Not should not be taken as HS plus ID. It is the length. Okay, so and V is your 2.26. So friction and loss in pipe is this. So now from suction to delivery, the total head is one is suction head, then it is delivery head, and other is that head loss in pipe. Okay, suction to delivery pipe, and this one is your delivery head, or sorry, velocity head. Okay, so putting these values, so we have this HS plus HD 20 and HF S plus HFD is 10.41, and this is here 2.26 square by 2 to 981. So that is your 30.67 meter. So manometric head is 30.67 meter, and overall efficiency is given as the power that manometric head can divided by the shaft power that is delivered to it. Okay, so power that manometric head can generate is your W into HM. W is rho to G. So this is rho, this is G, this is Q, and HM is your 30.69. And now if we want to calculate shaft power, we will divide it by overall efficiency, and overall efficiency is 70%. So shaft power will be your 17190 watt or 17.1 kilowatt. So answer is 17.19 kilowatt, and so answer to question number 46 is B, and answer to question number 47 is A. So that is 30.67, and other one is 47, that is 17.19. Okay, next, a centrifugal pump is required to pump water to an open water tank situated at 4 km away from the location of the pump through a pipe of diameter zero point 0.2 meter having Darcy's friction factor of 0.01. The average speed of water in the pipe is 2 meter per second. If it is required to maintain a constant head of 5 meter in the tank, neglecting other minor losses, the absolute discharge pressure that at the pump exit is option A point 0 point 0 sorry point 449 bar, option B 5.503 bar, option C 44.911 bar, option D 55.23 bar. So here the length of pipe is given 4 km or that is 4000 meters, and diameter of pipe is given 0.2 meter, and Darcy's fraction factor is given 0.01. So average speed is given 2 meter per second, and head at the pump exit is 5 meter, and head loss due to pressure is given, that is fraction factor. So that way, so the formula will be FLV square by D into 2G. So HF comes out if we put L as 4000 and D as 2 meter per second. So and D as 0.2 meter, diameter of pipe is 0.2 meter, and head loss in pipe is comes out as 40.77 meter. Okay, so this is the head loss in pipe, uh, and atmospheric at the exit there is atmospheric pressure. Okay, so and head loss in pipe is this 40.77 meter, and head at the exit of the pump exit of the pipe is 5 meter. Okay, so that is the total head at the exit of the pump. Okay, so because this is the head loss in pipe 40.77, and this is the head at exit of the pipe, and at exit the pressure is atmospheric, so that is 10.3. So total head at the exit of the pump should be or the head that is required, total head that is required to maintain at the pump exit is 56.074, and this is your this is the head in terms of water. So total absolute pressure is rho gh. So this will be 1000 into 9.8 into 56.074, or 55085 Newton per meter square, or 5.50085 bar. So answer is B. Next, the diameter of an impeller of a centrifugal pump at inlet and outlet are 30 cm and 60 cm respectively. The pump works against a head of 30, and the minimum starting speed of the pump is option A 750 rpm, option B 891.8 rpm, option C 1000 rpm, and option D 918.1 rpm. So here given these are the data given, diameter of the inlet and outlet are given, that is 0.3 and 0.6 meters, head generally is 30 centimeters. Okay, so the head generator the head generated in centrifugal pump is difference in velocity head at the exit and at the exit and at the exit. So at the exit suppose velocity u2, and at the entry the velocity u1. So that is the maximum head that the pump can generate. So that is u2 square by 2g minus u1 square by 2g. So that is the maximum head. We neglect all the losses, then that is the maximum head that the pump can generate. Okay, so that is equal to, okay, and u2 is given as pi by d2 by d2 and by 60, or that is d2 is 0.6, so it will be 0.031 for n, and d1 is your 0.3, so that is 0.0157 n. So putting these values here, and HM is given as 30, so putting these values here we can find out n. So n comes out as 891.8 rpm. So answer to question number 14 is B.